In this video, we're going to solve a simple circuit problem. The question says, find the effective resistor given this circuit, the total resistance in this circuit, total current, the total current through the circuit, voltage across the parallel connection, the voltage across these two parallel resistors, and the current through ohm resistor and the current through 15 ohm resistor. So let's see how to solve this simple circuit. Solution: first we need to find the effective resistance, and for us to find the effective resistance, we can see here there is a parallel connection, so we need to make this parallel connection into 1 ohm resistor. And we already know from our previous video that the total parallel resistance in 2 ohms R parallel equals to the product of the resistance divided by the sum of the resistors. So this would simply be the product of these two parallel ohm resistors, that is 10 multiplied by 15 divided by the sum of the two parallel resistors, 10 plus 15. R parallel would be equals to 150 divided by 25. Therefore, R parallel equals to 6 ohms resistor. So we can now redraw this circuit, which will simply looks like this, making these two parallel ohm resistors into 1 ohm resistor obtained as 6 ohm, and in series with 4 ohm resistor given in the circuit. So now we can simply find the R effective using this circuit, and this R total would be R1 plus R2. Let me name this as R1 and this as R2. So R total would be 4 plus 6, which is 10 ohm resistor. This is the R effective. Now let's move and find the total current through the circuit. So as we already obtained the effective resistance as 10 ohm, then from the given circuit, voltage equals to 12 volts and I equals to unknown, the total current through the circuit. And from Ohm's law, we know that V equals to IR. So then we make I subject because we are after I. Then we divide both sides by R. Let's go with this. I total would be the value of voltage divided by the total resistance, which is 12 divided by 10. And this 12 divided by 10 will give us 1.2 ampere. I total equals to 1.2 ampere. And question 3 is to find the voltage across the parallel connection, the voltage across this connection. So always to find the voltage across parallel connection, we need to find the total parallel resistance. And here is the total parallel resistance as we obtained 6 ohm. Therefore, we have R total equals to 6 ohm. Then BP, that is the voltage in parallel resistance, equals to unknown. Then we are going to use I total in this case, and I total we obtained it as 1.2 ampere. 1.2 ampere. Therefore, from the formula, Vp equals to IRT, I total RT. This RT is the total ohm resistance in parallel resistance. Then this BP would be 1.2 multiplied by 6 ohm resistor. Therefore, BP equals to 7.2 volts. You can always realize that the parallel voltage always decreases from the normal voltage given in the circuit. The normal voltage was 12 volts, and now the parallel voltage obtained is 7.2. So now let's see the last solution. It says currents through 10 ohm resistor and the current through 15. So to obtain the current through 10 ohm resistor, we're going to use the formula I under 10 ohm equals to V divided by R under 10 ohm resistor. But now we are not going to use this voltage. We are going to use the voltage across the parallel resistor, which is this, as we obtain 7.2. So this would be BV. And now I under 10 ohm resistor would be the parallel voltage 7.2 divided by the R under 10 ohm is 10 ohm resistance. And now the current would be 7.2 divided by 10, which is 7.2 divided by 10, and this will give us the value of 0.72 ampere. 0.72 ampere. Now the current through 15 ohm resistor would be I under 15 ohm equals to B parallel divided by R under 15 ohm, and this would exactly be 7.2 divided by 15, and this will give us the value of 7.2 divided by 15, 0.48. 0.48 ampere. Thanks for watching. Please don't forget to subscribe. Thanks, which Abdul.